Hello, everyone. Um, I get a lot of questions about the type of problems that you see here in question 12 in in one of the example questions. Um, so I decided to record um, this tutorial here to explain how you approach solving this kind of problems. Now, this problem comes in different variations. My approach is always try to draw the frames uh, traveling between the stations and then try to find the solutions by looking at the diagram, by looking at the picture. So this is what I'm going to do right now, and I'll let you solve similar problems using the same technique. So the question says we have a transmission system that has three hubs between nodes 1 and 4. Each node uses its own transmission bit rate, as shown here. So we have 1 megabits per second, 2 megabits per second, and 1.5 megabits per second. Uh, we are assuming multi-pair cables used between the nodes, and we have these are the media type and the distance. So based on this information, we can find out the propagation time and the frame transmission time. So we need these two pieces of information. Now, the question asks for the total elapsed time to send 10 packets from node 1 to the last node, from node 1 here to node 4. Um, Assuming that the first node sends 10 packets one after another without a break, so we don't have to wait for acknowledgement, ignore acknowledgement. Assume the remaining nodes send packets as quickly as possible after a packet arrives. Comment on any buffering assumptions that are necessary. Okay, so this is what I'm going to do here on the uh, this side of the screen. So before I start, I need to find out the propagation time and the frame transmission time for each one of these nodes, each one of these hubs. So um, from table 4.1, we can find that the propagation time for twisted pair is about 5 microseconds per kilometer. Okay, and since we have 1 kilometer between node 1 and node 2, so the propagation time for uh, the first hub, TP1, is 5 microseconds. Okay, transmission time, frame transmission time is 1000 octets divided by 1 megabits per second. So if I want to find the TF, it's the length of the packet divided by transmission rate or data rate. And in our case is 1000 divided by 1 meg. So I get 1 millisecond. Okay, so this is micro and this is milli. Okay, so I don't need to calculate the others actually, because I know that the distance here is twice as much as the first hop, so propagation time is 10 microseconds. Here is 10 microseconds. The TF here is twice as much as this one, because it has actually half of this one, because the rate is higher. So I don't need to do the calculations for the rest. Let's start by looking at how frames are transmitted from the first node to the second node. So I can't draw this into scale, otherwise this will be a lot bigger than this one. So what I will do is I will draw a line here and assume that this one block represents 5 microseconds, and then maybe choose something like this to represent the transmission of one frame. So this is frame 1. Okay, frame 2, same thing. I am sending packet soon after the first one. And I can continue 10 frames here, but just to save space, I'm going to ignore the remaining frame and just draw the last one, frame number 10. Okay, so you should understand that these are frames being sent here. Okay, so between, if this is 1, and this is 2, and this is 3, and 4. So 2 cannot send the frame until the first one is received. So it will start sending from this point. Propagation time, because it has 2,000 kilometers, or 2 kilometers here. So the propagation time will be twice as much as TP1 here. So TP2 will be two squares instead of 1. So the frame will start here, and it will reach the second or the third node here. Okay, how about TF? TF, the rate is twice as much as the first time, so the rate will be, the frame will be sent in half of the time, so it will be sent around this time. The second frame will arrive later, and it will be sent also immediately after that. And then same thing happening for frames 3, 4, 5, and so on until we reach this last one. The last one will be sent sorry about the lines here are not straight, but you get the idea. Okay, so this is how much time we need to send from node 1 to 2, and then from 2 to 3. Okay, so we'll continue from 3 to 4. So from 3 to 4, node 3 will send as soon as it receives the first frame completely. Okay, how about the propagation delay? Propagation delay is the same. It's the same 2 kilometers. So again, it will start from here and will send will send. So there are 2 blocks here. Remember, 2 blocks here and 1 here. Okay, second one. Actually, we are still talking about the first one here. Second one will start transmitted or start transmitting soon after it arrives. Oh, forgot one thing here to mention. How about TF? TF, so we know the propagation time here is the same as this one. But how about the frame time? The frame time is 1.5, or the rate is 1.5 megabits per second. So it is faster than this one, but slower than this one. So I'll choose to take a point here. Instead of 1 block, I'm gonna take 1.5 blocks here. Same thing with the second frame. It will start sending here and it will arrive somewhere here, and then okay. Finally, the last frame, it will start transmitting as soon as it's completed, received completely at node 3, and then it will be sent also to the final node. So remember, there are nodes in between that I didn't draw just for to keep the diagram simple, but there are frames here. Right. So the question is, we need to find out the time between here, the start of the transmission of the first frame, up to here, where the last frame is received at node 4. Okay, so what is this time? Let's see. We have this time here. This is 10 TF1, right? We have 10 frames. Each one takes TF seconds to reach the destination. Okay, and then we have this piece here, which is equivalent to this piece, which is TP1. This is equivalent to this, right? And then we have this piece, which is TF2, the time to send the frame from node 2 to node 3. And how about this? It's TP2, right? This is the same, this part is the same as this part. So TP2, this one is TF3, because it's the time to send the frame from node 3 to node 4. So this is TF3. And then finally, this piece is the same as this piece, which is TP3. Okay, so the total time equal 10 TF1 plus TP1 plus TP2 plus TP3 plus TF2 plus TF3. Did I get this right? So 10 TF1 is here, TP1, TP2, TP3, I wrote them here, and then TF1, TF2, and TF3 here. Now, remember, they are related to each other. So if I put all terms relative to these two values, I know that TP2 and TP3 are actually twice as much as TP1. So TP1 plus 2 TP1 plus 2 TP1. If you want to put the numerical values, that's fine too. TF2 is half as much as, you can put the numbers, but so we'll put the numbers. So this is TF2 over the TF1 over 2, right? Because it's the time frame, the rate is high, is twice as much. So so the time is half. And finally, the TF3 is actually TF1 over 1.5. If you want to simplify this further, so this is, I think you can do the rest by yourself. So TP, so this is 5 TP1, and then you figure the rest. So you can come up with the number at the end, right? Make sure that you verify all of my equations here, make sure that's correct. Okay, so I think that explains how this kind of problems be solved. Always draw the diagram and then figure out the answer from the diagram. All right, thank you.